Well, hello everyone, and welcome back to Adrian's Digital Basement 2. We're going to be looking at a CRT today. And no, it's not the CRT here on the Model 2. It's this CRT right here. I just turned on a studio light. Hopefully that's a little bit more visible, but check out this cute little monitor. This was a recent save from E-Waste Destiny, and hopefully it works because it's in decent shape and it's pretty cute. It's like a little cube. This little monitor is very reminiscent of a security camera monitor, and very early on with 8-bit computing, people were using these types of monitors, well, specifically with the Apple II, because it was a relatively cheap and easy way to get a high-resolution monochrome monitor, which works perfectly with the 80-column display on an Apple II. There were advertisements showing the Apple II with a monitor like this. Now, it wasn't this particular monitor that was used in those ads. I think it was a Sanyo monitor. On the lower part of the front of the monitor, we have the brand name here, which is USI, and the model number, which is the Pi4. So it's like the Raspberry Pi 4's early cousin. This is obviously a flip down cover for the controls, and there's a little tab here, and I don't know if this comes across in the camera, but it should be about from there to there, and it's snapped off on one side. So that's unfortunate, but it still does work. It's very stiff, but the little catch is there, which is good. We can flip this down and see what's inside. Well, we have a simple set of controls here, a power switch, contrast, brightness, vertical hold, and horizontal hold. There's a little power LED here as well, but it's actually just above where the door is. So when you close it, you can still see the power LED there. On the top of the monitor, there is a convenient plastic carry handle, which actually offers really nice grip for moving this around. On the manufacturer sticker here, it's USI International model number EV-9031A. Manufacturing date, July 1982. And notice here that it is dual input voltage, so 120 volts AC, but also a 12 volt DC input. Notice the power difference there, 33 watts on AC and only 15 on DC. And that's because almost surely whatever regulation is happening in this thing for AC sucks up a lot of power, probably as waste heat and resistors or whatever, so you get a lot more efficiency if you just go right to 12 volts. Lower down, we have the mains input, we have the 12 volt DC input, and then we have a toggle switch that says display, and it has data and picture. So I assume that means data or video. And then we have a couple controls you can access through the back cover, V-linearity, vertical size, and a focus control. And then this switch here, which is labeled DC restoration off and on, is an interesting one. DC restoration has to do with the way that on some monitors, well actually most black and white monitors, the contents of the picture itself affects the overall brightness of the image. And I think DC restoration on helps it actually maintain a very consistent brightness all the time, no matter what the content is. We'll have to test that if this monitor actually works. But from my understanding, when you have a monitor that does not have a DC restoration function built into its circuit, then when you have very little information on the display, like say it's mostly black screen, then the overall black background actually appear gray. But if you have bright objects on the screen, it will bring the black level down. And I guess for regular television viewing, seems like most black and white TVs I've seen don't seem to do a good job here. It just doesn't lend itself well to computer display use though, because you end up with that changing brightness, which is kind of annoying. Next up is the impedance switch, which has a 75 ohm setting and a high setting. You would use the high setting if you want to connect multiple monitors together with the same video output, like you have one computer and you're hooked up to 3 monitors. The very last monitor should be set to 75 ohm, but all the other ones should be set to high impedance. For normal composite signaling, the last monitor in the chain, or if it's the only monitor, should have 75 ohm resistor to ground, and most televisions do all the time. But some computer monitors, especially ones designed for security camera purposes where you might have multiple chained together, you want to do it only on the last one. There are 2 video input jacks here. We have a regular RCA, and we have this very old style coax screw type connector. It's sort of like the predecessor to BNC. And then we have an interesting switch which I've never seen on a monitor before. It's a polarity switch for normal and inverse. So that should flip the picture between a black background and a white background, maybe to improve readability in some circumstances on certain machines. And then the last control is the horizontal width coil, which I notice seems to be broken. I'll have to take the back cover off to see what's happening, but I might need to use a tool, actually like the one I'm using as a pointer here, to adjust the width coil while the monitor is running. And that's really it for the tour of this monitor. Before I turn it on though, I definitely want to take the cover off and take a look at what's going on inside. Okay, so for the width coil, it looks like this is actually very similar to one of the tools. It just has a knob on it, and unfortunately the knob seems broken. The plastic on the knob is just completely broken. So if I snap it off the rest of the way, whoop, there's stickers falling out everywhere here. X-ray warning, okay, no big deal. And there is a label for the picture tube type, the MI1009H5ET. So with that broken knob taken off the back, I can actually just slide this right out. This is what was inside the width coil. No big deal. Because like I said, adjustment tools just like this, in fact, this is the exact one, can adjust the width coil without any issue. So I'll just rely on sticking a tool like this through the back cover, no big deal. One thing I like about this design is that there are no vents on the top of the screen. Actually looks like there's a little bit of a vent inside the handle. That just means that dust can't just float into the vents and collect inside the monitor. Obviously, if it's operating, it's gonna get dusty, but it won't really get dusty just sitting there stored. All right, well, I'm kind of excited looking inside of this monitor because it actually looks relatively clean in here. I mean, there's a little bit of signs of use, but overall, this thing's in quite nice shape. So whenever I have old TVs on the channel that don't have a composite input, they're only RF, people often say, oh, you know, composite mod the TV to add composite. That would make the TV a lot easier to use with computers or anything else, avoiding the whole RF and all the static interference that comes with it. But the one problem is most of those little consumer television sets are live chassis. And I mentioned that before. It just means that they use a very simple voltage regulator to take the mains voltage and lower it down to whatever the TV needs to run all the circuitry. Well, this monitor, on the other hand, it uses a transformer. So the mains just goes right into the transformer and probably puts out around 12 volts, which is similar to that DC input on the back. And that means that this entire chassis is isolated. Because when you have a transformer like this, you have a primary, which would be the mains, and you have a secondary, that would be the output. And those are separated from each other. They're not touching each other in any way. So you are safe to do a composite input on this, and you're not going to worry about accidentally sending 120 volts or 240, depending on where you live, into your computer through the ground lead. And that could easily happen if you have an unpolarized plug and you flip it around, or maybe one of your outlets is not wired up correctly. That's the danger with live chassis sets that you just don't get with computer monitors. So almost always, at least all the computer monitors I've ever seen, always seem to have a transformer inside that takes the mains voltage and converts it down to a lower voltage and also does that isolation. If I took one of those live chassis TVs and I hooked up an isolation transformer to it, then I could do a composite mod safely. But I don't want to lug around a large transformer just to run that set all the time, because if you don't plug that in, then you're in danger again. So here's the label for the CRT, and it says CPT. I wonder if that's Clinton. Clinton was used in Macintoshes and stuff, which obviously are a little bit newer than this particular monitor. But there's that same part number again, and the EIA code 577. But like I said, this whole thing is actually really clean inside. I mean, you can see there's a little bit of black coming off on my fingers there, but it's not so bad. That kind of gives me the impression that this monitor wasn't used a whole lot, which just specifically means that the CRT should be in good shape. Because I've talked about this on the channel before. I'm just wiping off the glass here so I can get a nice clear look inside. I've talked about this before, that CRTs, like any vacuum tube, because that's what it is really, are consumable. The emissions from the cathode that go to the CRT that light up the phosphor on the front, well, over time and use, the whole thing just gets dim and wears out. So the less use a monitor has, the more likely it is to have a nice bright picture and work well. So I've been looking around the monitor for some additional hidden controls, and here's one right here. There's a sub-brightness control, and you just have to remove that back cover to get to this. These other three controls can be reached while the cover is on. Anyhow, everything inside this monitor looks to be in tip-top shape. None of the capacitors have leaked visibly or are bulging. Everything just looks ready to go. So I think it's time to power this thing up. Before I turn this on, I'm just going to turn the brightness and the contrast down all the way. And I do that in case there's something wrong with, say, the vertical deflection. You'll get a solid line across the screen. That could easily burn in the CRT, and the CRT does not appear to have any burn in at all. So turning that down is just a little bit of a safety measure. Of course, if you start to see a line, you can also kill the power right away, but let's turn it on. Okay, I can hear it running. That's a good sign. We're not going to see any picture. Of course, I have nothing connected, and with these controls all the way down, let's turn the brightness up. Hey, it's amber. It's an amber CRT. Wow. Wow, wow, wow. That was very unexpected. I was expected that these types of security monitors would always have a white CRT because that's typically what you're going to be looking at, black and white cameras. I'm pretty sure that USI must have taken a normal security camera chassis like this, added the amber CRT in, and then marketed it towards computer users, because in '82 when this came out, I don't think Apple even had their own computer monitor by then, or maybe they did. The Monitor 3 might have been out. But amber was all the rage in the early '80s, and that they stuck it in here. All right, well, that rolling you see is, I don't see that with my own eyes, and that's because the oscillator in here is free running right now because there's no signal, so it's not running at 60 hertz, which is what the camera is currently running at. Let me plug in an input source. So brightness, we're still seeing nothing, but let's turn these other knobs. Aha, there it is. Oh, a very scratchy potentiometer there. Very scratchy indeed. So I'm definitely seeing some interference on the picture, and I don't know if that's coming across. All right, hopefully that is staying in focus. So this is a color signal going into this monitor. So of course, you're gonna see the NTSC dot pattern, but there are also these wavy lines that I'm seeing in the patterns, like in this white section right here. And I wonder what is causing that. That's an interesting effect. This is the inverse switch. So that's kind of cool. It's just inverting the cathode drive, I assume. Yeah, but you can kind of really see those wavy patterns there. So maybe those are coming across in the camera. Okay, the next switch is the DC restoration switch. So when I turn it on, looks like the switch is a little bit dirty. Makes it all very dark, but that might be okay. Let's turn the brightness up here. All right, so on these NTSC color bars down here, there are these 3 bars that are down in the black area. You should really only be able to see these 2, but right now you can see all 3. So that means the brightness is a little too high. So you want to turn it down just so you can make out these 2, which I can now. All right, now here's a bounce signal. Now what this does is the signal generator alternates between a white field and a black field. And you notice when it goes to white, you get a little bit of that weird juddering. Now that's that DC restoration function. Let me turn this back to off. Turn the brightness down. All right, so actually with the function off, you'll notice here, not only does the picture kind of lose sync and roll a little bit, but also the difference between the black and the white is almost the same. I mean, there's a little bit of a difference, but it's not much. This would not be a problem with a color monitor, which has a really good DC restoration function. But this DC restoration function should be on to offer a more consistent image. And there, I just turned it on. And even though there's a little bit of a pulse there, that's just that circuit's a little slow to respond. At least it's working a lot better than when it's off. And I can tell you for sure that those monochrome TVs that I've had on the channel do not do a good job at this. And if I input this signal into those, they would have that problem where the black and the white would look very similarly gray. Now I have a feeling there's going to be a viewer watching this who has a better explanation than me for what this does and why this is a good thing to have on, or maybe why you don't want to have it on. And check it out in the comment section. I'll pin that comment if I see it. All right, the width coil does work. On a coil like this, there's a lot of turns. You have to turn it a lot. Now on a monitor like this, you can use the horizontal hold to try to center it. It's not ideal because you can sometimes lose sync like that. So you can also use the centering rings on the CRT. Here's that invert switch. I just think it's kind of funny, but interesting those patterns. This is a really high frequency noise that's happening. So I wonder where that's coming from. I'm going to shut this down and I'm going to power this off 12 volts DC, see if those patterns are different at all. Now you might have noticed earlier that the DC input is actually center negative. I was just checking that with the multimeter, so make sure you don't hook it up backwards. I have no idea if this has any kind of diode protection in it. So the mains input is disconnected from the wall. There is no switch setting on the back for DC or AC, and it is funny that the cable is permanently attached. You can't even unplug it. But up out of sight of the camera, I'm going to turn on the bench supply for 12 volts at 2 amps. Okay, there is no current draw right now, but of course the set's off. There it comes. And on the bench power supply, it's drawing about 1.19 or 1.2 amps, which is kind of right around what it says, like 15 watts or so. That's not bad. I am seeing this interference pattern on here though. So clearly that has nothing to do with like a ground loop or the regulator for the mains voltage input. Although it's funny because down here, it actually is looking perfect now and the interference is only on this top part of the picture. Now, interference patterns like this definitely reek of capacitor issues, and it will be on the cathode drive circuit. So this is like what's actually driving the picture itself. So the signals that come in from the video connector and make its way to the picture tube are processed by circuitry, and somewhere in there, there is interference. Now it's weird because it's very high frequency. It's much higher frequency than even like the 15 kilohertz that this horizontal sweep is. So I'm not sure where that might be coming from, but I can tell you for sure that down here it's actually perfect now. The interference is only at the top here. I'm going to switch to something else besides this crosshatch. All right, and even on the color bars here, it's the same thing. I know it's inverted right now, but the interference starts about midway up. This section has it, and this section doesn't. Very odd. Now there's this switch down here next to the DC input that's between data and picture. It's currently set for data, and I assume that has to do with like a sharpness setting. Probably nothing else than that. All right, yes, I can confirm that it is exactly what I said it is. It's a sharpness control, and on data, it's almost like you have the sharpness turned all the way to 0, which is good. That's how it should be. But when you switch the switch over to the picture setting, which I assume is video, it's gonna sharpen the overall image. Now, what that does is called peaking. So when you have a high frequency signal, like over here where these lines are very close together, it's gonna enhance the edges on this section. So when I flip the switch, it gets much brighter over here, but it doesn't affect this side over here at all. It only affects over here. This can help a little bit when you're looking at low resolution video, like over RF, but it's not ideal. You don't really wanna add artificial sharpening when you don't need to. And even though I've been running the monitor for a little while, definitely the interference pattern starts about here. It's in this upper section and it hasn't really moved much. So I'm gonna shut the power supply off and I'm gonna switch back to mains, and let's just see if it looks any different, because it certainly was taking up the entire picture when I had it hooked up on mains. Okay, yes, the interference is worse and it's over this lower area as well. Indicates there are capacitors that probably need to be changed out on this thing. Well, luckily sets like this are really designed for service, and the bottom cover just comes right off, giving you access to everything you need to check all the capacitors on the main board at least. And there are a few more caps on the little board on the back here that had the invert switch on it, but don't know if that's actually handling any of the cathode stuff. The cathode drive is probably all happening here on the main board. All right, so I figured out some stuff on this CRT. Hopefully you can see the interference pattern on the screen here that I've been talking about. And I'm currently powering the monitor off my bench supply. And watch this. See the interference pattern? Look, it's gone. Now, what exactly am I doing to make it go away? Or for instance, I can make it come back. Turn it up. There it is. It's fully back there. I'm adjusting the voltage going into the set. Now, obviously, if I'm adjusting the voltage, I am currently powering this off the bench supply up there, and where the interference goes away is around 11.6 volts or so. And I took some measurements. Actually, let me turn this off and turn it around. All right, so I'll unplug this cable since it's not very long. All right, so I took some measurements. What's happening when you run it off the mains is it goes right through this transformer immediately, and then it goes through a bridge rectifier, which is on the board. There's actually 4 discrete diodes, and it outputs around 14 and some volts. And then it goes through a voltage regulator, which is right down here. There's actually like a little potentiometer for the B+ adjustment, and it's a simple bleeder resistor type regulator. where there's a large power resistor, and it will bleed off any additional voltage to get down to the B+. Now, if I flip this onto its side here, this right here is the voltage regulator for this monitor, and that is the potentiometer for the control. All right, the monitor is plugged into the wall and currently on. Oh, okay, well, it's doing something else. Let me move the camera. So this is the other thing it's doing, and I know you can't really see what's going on, it just looks like a solid screen, but it's currently powered off the mains and there's no interference whatsoever. And this has happened a couple times where it's just gone away. And if I bump the monitor, I'm gonna use the back of the screwdriver here just to give it a little bump, and the interference is back. I have no idea if that interference is showing up on the camera when I'm zoomed this far out, but it was completely gone and now it's back. So that implies that we have a bad connection somewhere, and most likely I would think this is a bad connection on a capacitor. The funny thing is that I've poked around on this monitor, like using this stick here, and I've poked all the components that are in the voltage regulator circuit, and nothing I do seems to make the interference go away. It just kind of happens on its own. So I'm gonna bump the board here on the back. Yeah, nothing. There's no effect at all. But more than once I've been poking around on here and all of a sudden I look and there's no interference. So I actually grabbed the soldering iron and I reflowed everything here in the voltage regulator section. I also took the magnifying glass and I inspected for any bad solder joints. I'm not seeing any on this entire monitor. The only thing I'm seeing is that some of the solder joints are kind of crystallized, but none of them look like they're not connected. And no matter how much poking I do on the board, oh, wow, okay. I just poked, and now the interference is gone. I was sort of poking around in this area. I know you can't see where I'm pointing. Let's poke around a little bit here, see if I can get it to come back. Actually, I'm gonna just stick it in this side here. So far, it's not come back. Oh, it just came back. Aha, I just found it. Oh, all that poking around and I couldn't find it. All right, I've locked the focus to manual. Let's see if I can get the interference to come back by poking the component I think is bad. Yep, I got it. Okay, it's not coming back now. Let me bump the monitor. There we go. Okay, the interference is back. Hopefully you can see that. But I'm gonna poke the component I think is flaky. Yep, there it is, it's gone. Well, there we go, enough poking around and I was able to figure it out. And it's funny, because before I started the camera, I poked around quite a bit and I was unsuccessful at figuring it out. The faulty component, or the one that's causing an issue, is this capacitor right here, or I think it's that. I'm gonna, oh yeah, just touching it makes the interference come and go. So let's take a look at the underside here. Let's see what cap that is. 607 it says. 607, it's right here. I'm gonna inspect that close up. Well, that is definitely a good solder joint. There is no issue whatsoever there. So I'm just gonna pull that part out and just replace it. And before I remove that, I forgot to say that I did go over the entire board using the LCR meter here, looking for bad caps, and every single cap on this whole set tests good. Nothing looks terrible. I realize now in editing, I didn't really talk about what this capacitor is doing. Basically, this is the filter cap for the output of the voltage regulator on the B+. And when I say B+, B+ I think stands for battery plus. Not quite sure actually, to be honest, but on a monitor, B+ is always what powers the entire monitor up. It's the main voltage that all other voltages in the monitor are derived from. The simple voltage regulator in this monitor is a bleeder type, as I mentioned earlier. It uses a large power resistor and a transistor and a little bit of a feedback circuit. Basically, there's a potentiometer to adjust the voltage. B+ on this monitor, I think is around 10.65 volts or thereabouts. So the reason why when I had it on the bench supply at 11 and point something volts and there was no more interference is because that entire voltage regulator circuit didn't really need to drop much voltage anymore, which meant that the power coming into the monitor from my bench supply, which is a nice clean linear supply, was pretty much passing through probably some diodes, which resulted in some voltage drop, and then it would power up the B+ of the monitor.
When the transistor on the voltage regulator gets involved to start bleeding off voltage, it probably is running at a relatively high frequency to do that, basically shunting extra voltage through the resistor, turning it into heat, and that's why we saw that high frequency noise. When that cap had a bad connection or whatever's wrong with it, basically that interference from that high frequency switching on the regulator would be seen. The design of the voltage regulator on this monitor definitely implies that you could power this up like, say, from a car cigarette lighter to run at 14.2 volts or whatever a car normally does, and it would still regulate down perfectly down to the 10 point whatever volts that this monitor needs for normal operation. And it also explains why running it off AC mains is so much more inefficient, where it has a much higher current draw. All that extra voltage, which is coming out of this transformer and the bridge rectifier of around 14 volts and change, is all getting bled off as heat. Running it right at 12 volts is much closer to the B+, so the regulator doesn't have to bleed off nearly as much voltage. All right, and back to the video.
All right, here's the capacitor. This is 220 microfarad, 16 volts. I mean, nothing special. It is not leaking. It doesn't seem to have any problems. And if you ever tried to use this wick, really matters that you buy good stuff. The cheap stuff is really hard to use and doesn't work very well. Not to mention it can get old and not work as well. This is MG Chemical's Super Wick Fine Braid, and I found this stuff works pretty well, and look, I'm almost out of it. I should probably buy quite a bit more of it because it's a good way to get parts in and out of boards nice and easily. Why don't we give this cap a test? Just plug this into the meter. Oh, it doesn't quite reach, or does it? There we go. I think the connection is not super good. 215 microfarad. Actually, it's kind of jumping around a little bit. When that happens, I have this little gizmo here, which you plug in to the tester here, and then I can clip it on. Well, there we go, 210 microfarad, but that D value is pretty high, actually. Let's see if it changes when I hit the cap. No, it doesn't really seem to do anything. I don't know. Let me find another cap of a similar value, and we'll measure that and see how it looks. All right, this is the replacement cap I found. It's 220 microfarad, but at 50 volts. I couldn't find a 16 volt part. This one's made by Sanyo, so I assume it's not gonna be crap. It's a little flaky there. The D is 0.4, 0.5, so it's way lower. I don't remember if I was testing the other cap at 1 kilohertz. Unfortunately, I gotta clean this thing because the little contacts there are a little crappy. Yeah, okay, so the D is lower, but honestly, a D of, what was this, 1 point something? Is not horrible, but touching it was flaky. So I don't know if the solder joint was bad. Like I said, I might be able to put this back in and have it work, but I might as well just replace it with this one, which we know is a little bit better of a cap, and let's see if that fixes it. Well, there we have it, turning it on. It's perfect, no interference. I'm powered off the main, so of course it's dropping about 3 or 4 volts across that resistor. Sorry, that's my phone blowing up. Let me put it face down so it goes into silent mode. Yeah, poking that capacitor, no more interference. Boom, that was it, it's fixed. Now, if we turn this monitor over like this, one thing that we can see is this cap is very close to this large heatsink here. And I think this is probably horizontal deflection. There's a big transistor right there. This probably gets nice and toasty, and it probably just baked that capacitor. Looking around on the inside of this large heatsink, there are no capacitors as close to it as that one was. So that's a really good top tip. Always suspect capacitors that are very close to things that get hot. So like the power resistor that's in this thing for dropping the voltage for the voltage regulator, anything near that might be a problem. And anything with heat sinks that are this large especially are probably gonna get hot. And when you have caps that are very close to them, suspect that those are faulty. Now, since I could poke that cap and it would go from working to not working, it didn't seem to be totally dead. And it definitely had capacitance still according to the tester, but probably had a bad connection on the inside, or I mean, it could have been a bad solder joint too. I didn't reflow it. Maybe that would have been a good test before replacing it, but whatever, I did take it out and it had a high D value. So yeah, this cap, I'm just gonna say it's bad. It's funny about what looked like leakage though, because there's certainly no evidence of that looking at this side. But anyways, it's close to that heatsink. It gets baked. There's also like a little electrolytic over here that's also pretty close. That one probably should be replaced, but the monitor definitely is not showing any signs of issue at this point. So I'm gonna reassemble this monitor and then I'll give it a little bit of a clean and hook it up to a vintage computer, because I know when I have a TV or a monitor on here and I don't hook it up to something, people always put comments that I should do that. So I'll be right back. And we're done. The monitor's back together. Seems to be working really well, and it's looking really nice as well. I gave the case a full clean. I put some 303 on the black plastic on the front to restore that black luster to the original plastic. There was some masking tape that was adhered to the top of this case and also on the side a little bit. It was very crusty and hard to get off. I don't actually remember if it was on this side or that side anymore because, well, I cleaned it all off. I used Goo Gone because this is metal, and that took it off really easily. And I cleaned up the case and it looks quite good. I mean, it's got scuffs and stuff on it, but other than that, the case really came back to life. Well, let me reboot this Apple IIc sitting here, and as you can see, the beautiful amber glow is visible. We're gonna load up Attack of the Petsky Robots by David Murray. You will see in a second that all is not perfect with this monitor. There's a little bit of a geometry problem on the left edge here where the picture kind of bows. Let me start the game. Maybe we can see that a little bit better once the game is running. The image overall is incredibly sharp. This has no issues whatsoever displaying 80 columns. But yeah, if you notice there's a little bit of a bow where this part here is closer to the edge than the top and the bottom. I asked my friend Frank, who knows a lot more about CRTs than I do, if he thinks that this is a problem with the electronics inside this monitor, or is it something on the deflection yoke perhaps that's not quite right. But otherwise, I gotta say, this monitor is amazing. The sharpness is just spectacular on this thing. And the only thing that lets it down besides this bowing is along the left edge, it's also a little bit less sharp. And it's only right here that's less sharp than on the rest of the image. Now you can control the left and right positioning, of course, by using this H-hold control. And I did adjust the centering rings. And it seems that the soft focus problem exists on this side of the picture. So if you move the picture way over here, then this part gets a lot sharper. Although the bowing doesn't really go away, like it's still bowed. So I think that might be in the electronics, but the sharpness problem, which I don't think is going to even come across in the camera, is strictly over here on this part of the screen. The CRT has absolutely no burn-in whatsoever, which is fantastic. It's incredibly sharp, as I mentioned, and it's very, very bright. It's probably one of my better amber monitors that I actually have in the basement, because it seems that amber monitors are extra susceptible to getting burn-in and also becoming dim over time. Maybe the phosphor is just not as reactive as the green and white, or there's some other reason, I don't really know what it is, but like I said, all the amber monitors I have some kind of burn-in and they're not very good, except for this one. Now, the whole time I've been working on this monitor, something struck me about it. It seemed so very similar in so many ways to the Sanyo monitor that most people use with their Apple I and Apple II computers. I'm sorry to be recording the screen, but this is a second channel video and that's just kind of what I do. It's a one camera thing. The monitor that everyone seems to use with their Apple II and Apple I machines is the Sanyo VM4509. And if you notice, I mean, just look at the front here. This door, the LED, it's all identical. The only difference, of course, is this probably white or silver metal badge here that says Sanyo. And on this monitor, it's black and it says USI and Pi4 here. Oh, I just noticed this little speck right here, which is actually a little chip in the paint. It's just exposing the metal behind it. So I'm just gonna take a Sharpie here. I'm just gonna color that in. I know that seems sketchy and crappy, but it's actually not a bad tactic. There we go. I mean, there's one over here as well, just a little scratch that has resulted in a little silver showing through. There we go. The Sharpie can come off if I need to, and it just isn't as distracting with a white spot there. Anyhow, not only is this door exactly the same, but if we open it up and look at the controls inside, take a look at the controls on this monitor versus the controls on the Sanyo monitor. basically 100% identical. Just to compare, here it is again. Even this little notch right here is the same. The little tab to keep the door closed is exactly the same. Everything about the inside here is the same. But wait, there's more. This is the back of a very similar vintage Sanyo monitor. And there you can see Sanyo model VM4509. It is also dual power supply with 2 different wattages. It's made in June 1983. It does say made in Japan. And notice all the text that's right here on this label. And here's the back of the USI monitor, which is model number EV9031A. The text that's written here is basically identical. Even the formatting of the label is not exactly the same, but almost exactly the same. Just the difference is here it says USI International, manufactured by Taiwan Kolin Co Limited, made in Taiwan. And on the Sanyo it says manufactured by Sanyo Electronics Corporation, made in Japan. Next up, look at the controls on the back of the Sanyo. It has a DC restoration switch, the impedance switch, video in and out. Notice it's these larger screw type connectors. And compare that to the back of this monitor, the mains input is off to the side a little bit, but it's got that recessed screw, has the same switch here and here and here, and then this says in and in, but almost certainly this is actually just in and out. And of course it has one of these screw type ones like the Sanyo, and then they've replaced this one with a regular RCA jack. Now the little bit of a difference is this is the focus switch over here, or focus knob that is, and then here and here are the V linearity and the V height, and they're moved over a little bit. So probably the circuit board that's actually inside of this monitor is different than the Sanyo, I'm assuming, because of the positioning is slightly different of these controls. So really, I just found it really fascinating that it's very obvious that there's a shared lineage between this monitor and the Sanyo one, but clearly they're not identical besides the amber screen, even though they're the same vintage. So it's almost like maybe Sanyo sold their design to Kolin in Taiwan, who made this monitor on license or something. I don't really understand that. So if anyone has any background information about what's going on here and why this monitor is almost identical to the Sanyo or vice versa, I'd love to know more about that. So there we have it. That is the USI Pi4 monitor made by Kolin out of Taiwan, and very similar to the Sanyo VM4509. Hope you enjoyed the repair of this monitor as well. My point with that was it's always a good idea to try to figure out what the fault is with something that you're working on first, before just replacing parts randomly. In my opinion, there's actually a little bit of risk by recapping a monitor for the sake of recapping it, because you might put a cap in backwards or put the wrong value in and actually cause damage to the monitor. When you have something like an ESR meter, you can test to see if the caps are within spec or close enough, like they are on this monitor, so that it's actually going to work fine with all of the original caps in here. And there was just that one faulty one which needed to be replaced, and that fixed it up completely. If you enjoyed this video, I'd love to hear about it in the comment section below. And of course, I would love it if you subscribe to this second channel. It really helps me out. It's just very interesting how YouTube really promotes channels with a lot of subscribers. And the more subs you get, the more exposure you're going to get, and the more people will see your video. So really, that does really help me out. Also, thanks to my patrons. Their names are scrolling up the side of the screen. Their support means a lot to me. If you want to become a patron yourself, you can do so at the link in the description below. And finally, I want to thank the person who gave this monitor to me. They saved it from e-waste, and of course, reuse is always a great thing, not to mention saving a cool vintage piece of technology like this, which is an awesome little amber screen. So thanks very much for watching. Stay healthy, stay safe, and I'll see you next time. Bye-bye.